So here, we are going to assume that individuals are, they have their preferences are represented by VNM utility function. Okay, so what that means is you just need Bernoulli utility function. If you have the Bernoulli utility function, then you can figure out the satisfaction level associated with any lottery by finding the expected utility of that lottery using that Bernoulli utility function. So basically, every individual is a Bernoulli utility function. You can think of it in this way. Their preferences can be represented by a simple Bernoulli utility function over wealth levels. Okay, so let's assume that. Okay, and now I'm going to give you definition of when do we say that an individual is risk averse at a certain lottery. Okay, so this is kind of a local definition. Okay, that when do we say that you are risk averse at this lottery, because it's possible that you might be risk averse at some lottery and you might not be risk averse at some other lottery. That's possible. Okay, you might so I'll give you that local kind of definition, which is a definition which depends on lottery. Okay, so we say that u, remember u is that small u, Bernoulli utility, because that's all that we need for even the capital U. Yes or no? Okay, so we say that small u is risk averse at lottery X if the following holds. Okay, if expected utility of lottery X, which is basically your capital U of X, right? Yes, is less than utility from expected value of X. Is this fine? So we say that a particular individual is risk averse at a particular lottery X if he strictly prefers the expected value of the lottery to the lottery itself, because this is a satisfaction level associated with the lottery itself, left hand side. This is a satisfaction level associated with the expected value of that lottery. So if I'll give you a certain amount, which is the expected value of the lottery, you will say that, okay, give me that expected value of the lottery. I don't want the lottery. Is this fine? So like, for example, if the lottery is 0 with probability half and 100 with probability half, we say that an individual is risk averse at this particular lottery if given a choice between a certain amount of rupees 50, which is the expected value of the lottery, to the lottery itself, individuals will say that give me the certain amount 50. Okay, so let me now define risk loving. Okay, we say that a consumer or an individual U is risk loving at lottery X if satisfaction level associated with the lottery, which is expected utility of the lottery, is greater than utility from the expected value of the lottery. Okay, this kind of a local which is at every lot, at a particular lottery we are checking whether a particular individual is risk averse or not. Okay, I'll give you also some global definition. When can we say that this individual is risk averse? Not like at lottery, but risk averse, simply risk averse. When can we say that? I'll give you that definition also. Is this fine? We say that U is risk neutral at lottery X. Risk neutral at lottery X if satisfaction level associated with the lottery is same as the satisfaction level that the individual will get if he's given the expected value of that lottery. Okay, so basically he's indifferent between the lottery and its expected value. In that case we say that this individual is risk neutral at lottery X. Is that fine? Okay, now let me give you the definition of when do we say that an individual is risk averse. Okay, so I mean, of course, this is risk aversion at a particular lottery, a behavior which is a behavior at a lottery or something like that. Okay, but can we say that, when can we say that an individual is risk averse? Simply, risk averse. We are not really talking about at a particular lottery, but we are just saying that this particular individual is risk averse. So there is a definition for that as well. We say that U is risk averse if U is risk averse at some lottery X, if there exists a lottery X, okay, such that U is risk averse at X, and for all lotteries X, the following holds. Utility from X must be less than or equal to utility from the expected value of X. So basically, this inequality becomes weak. So this weak inequality should hold over all lotteries, and there must be at least one lottery on which this inequality is strict. Is this okay? Okay. Similarly, we can have a similar definition for U being risk loving. Okay, we say that U is risk loving if there exists a lottery X such that U is risk loving at that lottery, and for all lotteries X, the satisfaction level associated with the lottery must be greater than or equal to the satisfaction level associated with the expected value of the lottery. Is that okay? So basically, those individuals who weakly prefers the lottery to their expected value, and at some lottery they strictly prefer the lottery to its expected value, we call such individuals risk loving. Is that okay? So now we can define risk neutral. So we say that an individual is risk neutral if the individual is indifferent between lottery and the expected value of the lottery for all lotteries. Is that okay? So this is for risk loving. Okay, so just replace this by risk loving. Okay, and now let me define. We say U is risk neutral if for all lotteries X, satisfaction level associated capital U of X. Remember that capital U of X is EU of X must be equal to U of E of X. Is that clear? Now, if you just look at this is nothing but, if you just look at this particular thing, U of X is less than or equal to U of E of X. This is nothing but the Jensen's inequality. Okay, Jensen's inequality, when we have concave functions. If U is concave, then this inequality holds. Yes or no? And if U is convex, then the opposite inequality holds always. So it turns out that we can say that U is risk averse if and only if U is concave and not linear. Okay, so I mean we because linear would give us risk neutrality. Okay, so we don't want that. I mean, as long as it's concave and not linear, we'll have an individual who is risk averse. Okay, and as long as we have convex and not linear, we have risk loving. Okay, and if we have linear utility function, then it's risk neutral. Okay.